Oh, okay, I could probably help him out with that. I'm sorry?
I didn't count by 20. I think it was 35 or 40.
It goes 40. There you go. So that's what I'm here for. Okay, so the end of the week, it's the end of the 6 weeks. We're going to start the 5th, 6 weeks next week. So on Monday, we're planning to go ahead and start the next set of identities, which are called double angle identities. And then we'll get into trig equations, and we'll just keep going and see how far we can get right before spring break. So we have 3 weeks until that happens. But I want to go ahead and wrap up the notes today. We're not going to go ahead and do every one of the problems. In fact, there's only one more style I want to show you that's left. So here are the sum and difference identities that we've been working with for the past couple of days. And it is not this one, it is this one, example 8 in your notes. That's the one that I want to go ahead and take a look at. It's the last style, and then I'll go ahead and give you your assignment, give you some time in class to work on it, and that'll be our week. Okay. So let's see. This problem, it says, suppose that sine of alpha equals 4/5 for a quadrant 2 angle, and sine of beta is equal to 1/2 for a quadrant 1 angle. Find the exact value for each of the following. Okay, so these problems here, just like on your assignment, it's going to tell you exactly what quadrant you're going to be in. So for example, I know that alpha is in quadrant 2. Okay, so I'm going to draw a terminal side right here. Now alpha is going to be the reference angle. We connect it to the x-axis. Now, what is sine's ratio? It's what over what? Y over r, okay? So we have the y value, we got the r value. So from alpha's perspective, we have the y and the r, okay? And I need to know what that base is. Well, we can use the Pythagorean theorem, or does anybody recognize it as a triple? It is a 3, 4, 5 right triangle, yes. Does anybody want me to run through the Pythagorean theorem to show that we'll get that? No? Now, there is just one thing. What am I missing? And it's on that 3. It has to be what? No, the 3 would have to be negative. Okay, because what quadrant are we in? 2. Okay, so that's where x is negative. All right. And we're also told that beta is in what quadrant? Quadrant 1. So in quadrant 1 over here, I'm going to go ahead and draw a triangle with reference angle beta. And I'm going to do the exact same thing. So sine here is 1/2. So if this is y and r, okay, so from beta's perspective, there's the y, there's the r. And does anybody know what the base would be? What? It is not 1. All right, well, let's run through. So the Pythagorean theorem would say that x squared plus 1 squared is equal to 2 squared. Square root of not 1. Well, let's see. What's 1 squared? 1 equals 2 squared? 4. So subtract the 1, x squared would equal 3. So that base has to be the square root of 3. And it's positive because we're in the first quadrant. Okay, so we don't have to worry about any extra signs. So is everybody okay with how I got the quadrants, how I created the triangles with the sides? Anything confusing anybody? Okay. So A says, okay, I want cosine of alpha. Now remember, cosine is always x over r. So the variable is going to tell you which triangle you want to look at. So this triangle, because alpha, so what's the x over the r? Negative 3 over 5. Okay, that one's done. Okay. Bless you. Now, I want cosine of beta. Okay. Well, now I want to make sure I'm in the other triangle because we have beta. Okay. So what would the x over r be in that triangle? Square root of 3 over 2. There we go. Now for C, this is when we start looking at my identities. Okay. Given all this information, I want cosine of alpha plus beta. Okay, now we're going to go ahead and expand this. Okay. Now remember, cosine liked to do certain things. Did he want to keep the products the same or alternate them? Okay, so cosine wanted the same, But he did change what? He switches the sign. So this is going to be a minus when I expand it. So we're going to look at cosine alpha, cosine beta, minus sine alpha, sine beta. Okay. So just like we were doing yesterday for each of these four, we just want to substitute the correct ratio. Like, for example, cosine of alpha. See, that's why we found these prior. What was cosine of alpha? Negative 3/5. I mean, even if we need to look back at the triangle, we still see it's x over r. So I'm going to replace cosine of alpha with negative 3/5 times. Now I need cosine of beta. Well, didn't we already find that too? Square root of 3 over 2. This is exactly what we were doing yesterday, only we're not having to use the unit circle. We're using the information that we were provided. Now, what about sine of alpha? There you go. See, we already knew that. It was part of the information given to me so I could work the problem. So instead of sine of alpha, I'm going to put 4/5 times sine of beta. What was that? 1/2. Okay. There you go. We have no idea what alpha and beta are, and we don't need to know. Okay. So now we just simplify this, and that's the end of C. So what is a negative 3/5 times square root of 3 over 2? Remember, how do we multiply fractions? Just straight across, right? So what's a negative 3 times square root of 3? Negative 3 square root of 3 over 10. Then we got the minus. That would be 4/10. Okay. So I would probably just go ahead and combine them since they already have the same denominator. I might just go ahead and say negative 3 square root of 3 minus 4 over 10. Or you could leave them separate. Negative 3 square root of 3 over 10 minus 2/5. If you wanted to do that, it's the exact same thing. But there you go. Again, we're just using the sum and difference identities. Okay. Questions. Okay. Now we want to do the exact same thing, but this time I want sine of alpha plus beta. Okay. All right. You want me to give you a few minutes to try that one? Okay. Let me give you a couple minutes using the same two triangles. We just want to expand this and then get whatever our final answer is going to be. Does anybody need help with the expansion? Okay. All right. So let me give you 2 minutes. And I can still smell it in here too. That burnt smell kind of came in from the hallway. It'd be nice, you know. Fresh air and math. Honestly, I don't know. Is that courtyard? I know they keep a lock on it most times. Is it still locked? Or?
What's it called? Miss Vendel, right down there. She has the keys to unlock it.
She does?
She's a horticulture teacher as well.
Really?
So her students go out there and plant like flowers. So as long as we probably don't destroy the plants, we could probably sit out there with whiteboards or something.
Nice. Need some whiteboards. But math and fresh air, I mean, that sounds like a perfect day.
And gummy bears.
And gummy bears?
Burrito, all of this. I'll pay.
You'll buy burritos for everybody?
Better get cheap. But yeah.
Unless we do it on Mondays, then we go to walk over to Taco Villa and get $1 burritos.
That's right, yep. The bean burrito Mondays, yeah. My sister loves those.
What's his name?
Hmm.
Yeah, I think we can. We should probably just go run around outside.
Just go run around outside?
Yeah, that, but yeah. We could make the angles.
Yeah.
For that show.
I can sell chocolate outside. Blow bubbles and calculate the radius.
There you go. Math is everywhere.
Why did you go to Dollar General and buy a bunch of bubbles? Yeah, I would. Give me a bag.
If I give you a fast, yeah, sorry.
I know that, but if I try hard enough, my car can fit 14 or 15 people.
What kind of car do you have?
It's a Chevy Blazer.
Oh.
We got some instant things. It only technically has 5 seats.
All right, well, that's 2 minutes. You may or may not be done, and that's okay. But let's take a look. Can anybody tell me, we're not doing the substitution yet, just what is the formula for sine of alpha plus beta? Is this one the sine cosine, or is it another cosine cosine? So it's cosine. We go ahead and alternate those. So sine alpha cosine beta, plus or minus? Plus. Remember, sine always wants to keep the same operation. So now it's cosine alpha sine beta. And see, we still don't even have to do really any extra work. We already know each of these four. Okay. What was sine of alpha? Yeah, that was what we were originally given. So I'm just going to replace sine alpha with 4/5 times. What was cosine beta? Square root of 3 over 2 plus cosine alpha. Negative 3/5. And sine beta. 1/2. Now, the only difference between this, I mean, you've already got the triangle. If you were given a measure that you had to use the unit circle, you'd just be going to the unit circle to get those ratios. Okay. All right, so let's see. 4/5 times a square root of 3/2. 4 square root of 3 over 10. Okay, plus, what would that be? Negative 3/10. And the 4/10 could reduce, but I think it's better just to go ahead and combine them into a single fraction. So I'd go ahead and say 4 square root of 3 minus 3 all over 10. Or you could say negative 3 plus 4 square root of 3. Order doesn't matter as long as you keep the signs accurate. And there you go. That is the last problem that I wanted to go ahead and show you. So let me pass this out. Here we go. So I took the original assignment and I went ahead and shrunk it down considerably. I just wanted to go ahead and give you enough to practice. I am going to bring something back next week that was a huge favorite among the students. Happy Minutes. But each Happy Minute next week is going to be a sum or a difference identity. Okay. All right. So I will have extra unit circles if you need one. Okay, you'll be able to use your notes, but I'll go ahead and give you, maybe 3 to 5 minutes to simplify each of those. Okay. So this right here, let's go ahead and say I have Pre-Cal IS's assignment due on Tuesday, so why don't we go ahead and have the same thing for you guys? Okay, let's have it due on Tuesday, sir. Well, yes, it is Friday, but we'll have it due on Tuesday. So let me go ahead and pull this up real fast. Bless you. Okay, so this is the assignment. So like we always do, why don't we go ahead and work a couple of these problems together and then see what you guys think. You'll notice it is number 10 that's just like that problem we were talking about. Now it is written a little differently. Here it says alpha is between pi over 2 and pi. What quadrant would that be? What quadrant starts at pi over 2 and ends at pi? That's quadrant 2. Okay. What about beta being between 0 and pi over 2? That's quadrant 1. Okay, it's just another way of writing it. Okay. So on 7, 8, and 9, you want to reverse the process. You want to take it back to a single trig function, and then you'll evaluate it. On numbers 1 through 6, you'll go ahead and expand it, choosing 2 values to add or subtract, and then just like we did yesterday. So which problem would you like to take a look at? Number 9. Okay, so number 9. It says tangent of 40 degrees minus tangent of 10 over 1 plus tangent of 40 tangent of 10. So this one, it's already written out for you. What you want to do is bring it back to a single trig function and then evaluate, get your ratio. So this one, obviously, would it be a sine, cosine, or tangent formula? It's obviously a tangent, right? So I know this is tangent, but here's the thing. We know alpha and we know beta, because remember, they always go in order. But what would this be right here? Would this be a plus or a minus? Minus. Remember, one thing about tangent, whatever operation you had, you keep it in the numerator, but then it's the denominator that takes the opposite. So this is actually tangent of 40 minus 10, which is actually tangent of what? 30. And see, 30 degrees is a value that we can take care of on the unit circle. Okay. You're going to want to do the same thing for number 7 and 8. Whatever you do with those values, whether adding or subtracting, you should get one that you're familiar with. So now let's go to the unit circle. Tangent of 30 degrees. Okay. So here's 30 degrees. All right, so here's the ordered pair. I want tangent of that angle. Well, what does tangent tell me to do? It's what over what? Y over x. Okay. So y over x. So I want to take the y value of that coordinate and divide it by the x value of that coordinate. So I'm going to take the 1/2. Let me get myself a little room down here. I'm going to take the 1/2, divide it by what? Square root of 3 over 2. Simplifying that will give me my answer. Okay. So what's that rule that we keep hearing over and over and over again? You divide by a fraction, you multiply by the reciprocal. So this would be 1/2 times, when I take the reciprocal, 2 over the square root of 3. So let's see, those 2's are going to cancel out. And then I've got 1 over the square root of 3, but there's just something about that I don't like. There we go, we got to rationalize it. So I'm going to multiply both parts by square root of 3, and that's absolutely right. Okay, the square root of 3 over 3. So I'm going to come back here to my paper. Square root of 3 over 3. It's got to be my answer. Okay. All right. Is there anybody who's confused by what I did? Any questions? Okay. Would we like to do another one? Okay. Like which one? Do we want to do numbers 1 through 6? One of those? Which one would you like? While you guys are doing that, I'm going to go ahead and erase this out of here. Okay. And you'll notice you've got some of these in degrees, but some of them are also in radians. So I would probably just tell you, take the radian measure and do what? Yeah, I just change it to degrees. It's going to be a lot simpler to work with. Like, for example, sine of pi over 12. Pi over 12, you multiply it by 180 over pi so that the pi's cancel. And in fact, we saw this, I want to say yesterday, 15. 12 will go into itself once, but 180 divided by 12 is 15. So this is just sine of 15 degrees. Okay. So don't worry if it has a radian measure. Just convert it to degrees. Okay. All right. So which one? Number what? Number 6. Okay. Oh, that's a good one. That's a tangent. So let's see here. First, we need to figure out what that measure is. So I've got 13 pi over 12 times, 180 over pi. Okay. So those pi's are going to cancel. 12 will go into 180. We just saw it's 15 times. So 100, well, 13 times 15. Somebody help me out. 15. Okay. Okay, so 13 times 15. He's absolutely right. Okay, so this is really 195 degrees. Now, does it matter if I add or subtract? No. As long as I get two numbers off the unit circle that will add or subtract to give me 195 degrees. Okay, so I'm looking at my unit circle. What do we have? Okay, what's that? We get 195. 195. I'm already thinking of one. Okay. Well, that's one of them. 45 and... Oh, well, I'm way off. What am I thinking? 150, yes. 150, yes. You're absolutely right. Yes. There you go. So 60 and 135. 150 and 45. There's going to be multiple sets that will give you the same value. And does it matter which one you use? Absolutely not. So let's run with Nathan's idea. He's going to say that tangent of 195 degrees is just tangent of 150 plus, what was it? 45, I'm sorry. Man, it is a Friday. Okay. So is everybody okay? All right, so let's go ahead and make this one alpha. Let's make this one beta. And it's just a matter of simplifying. Okay. So let me go back over here where I have some room. Get rid of this. So tangent of 195 degrees. We're going to say that's tangent of 150 plus 45 degrees, alpha, beta. Okay, so let's go ahead and plug this in. So we know we're going to have tangent 150, tangent 45 up top, tangent 150, tangent 45 up top. Will it be plus or minus? Plus. Remember, whatever operation you choose to use for tangent, you keep the same operation above, but below, that's when you change it. So down here, it would be 1 minus, what am I going to put there? Tangent 150, is that it? Times tangent 45. There we go. Okay. So really, I only need two things in order to continue the problem. I need to know the ratio that equals tangent of 150, and I need to know the ratio for tangent of 45. Okay. So let's go on over to the unit circle. Okay. Let's do the 45 first. So here's 45. Here's tangent. Now that was an excellent choice because tangent is y divided by x. So what is the square root of 2 over 2 divided by the square root of 2 over 2? 1. So the tangent of 45 is just 1. Okay, so we come back over here. Tangent of 45 equals 1. That one's easy. Okay. Now we need what? Tangent 150. Okay, so we're going back to the unit circle. So here's 150. Okay. So I want to take the y value and again divide it by the x value. I want tangent of that. So let's see. The y value being 1/2. And I'm going to divide it by the negative square root of 3 over 2. Actually, didn't we see this one a second ago? Okay. Does anybody remember what it's going to come out to? The only thing that's different now is that the denominator is negative. Okay, so it would be negative square root of 3 over 3. Yeah. Okay, so I'm going to come back over here. Tangent of 150 equals the negative square root of 3 over 3. There we go. Now it's just substitution. Is everybody okay with what I've done? How we got to 195, where we got 150 and 45, these fractions, anything. Okay. All right. Well, now it's just substitution. So this one right here, the tangent of 150, I'm going to replace it with its value. So negative square root of 3 over 3 plus, well, what's the tangent of 45? 1. over 1 minus tangent of 150. So that's going to be a negative square root of 3 over 3 times what? 1, tangent of 45. So let's clean this up a little bit. Up top, I'm going to have the negative square root of 3 over 3 plus 1 over. What happens when you multiply anything by 1? Yeah, it stays the same, right? But what happens when you subtract a negative? Okay, so that would be 1 plus the square root of 3 over 3. Okay. Now that right there is the tangent of 195, but remember, we don't want to leave it like that. Okay, we want to get rid of the radical. In fact, we saw one like this yesterday.
Yeah, multiply top and bottom by 1 minus square root of 3 over 3.
We can absolutely do that, and we will. You're right. We're going to use the conjugate, but a lot of people don't like to work with the fractions. So what can I do to get rid of both those fractions? There you go. The denominators are both 3, so why don't I just multiply by 3 over 3? Again, I'm just multiplying by 1. I'm not changing his value. I'm just making this problem a lot easier for us to work. Okay. So what would 3 times negative square root of 3 over 3 give me? Negative square roots of 3, right? Because those 3's would cancel. Okay. And then 3 times what? So plus 3 over. Now we distribute here. Well, that would give me 3 plus square root of 3. Now, see, you don't have to do that. You could absolutely work with the fractions. I mean, who wouldn't, right? Because they're fun. Okay. But a lot of people probably like that expression better than the other one. So now we've got to multiply by the conjugate. Okay. So what's the conjugate of 3 plus the square root of 3? There you go. All you do is change the sign. 3 minus the square root of 3. Okay. So now we're going to go ahead and FOIL. And actually after that, we should be really close to being done. How do I FOIL again? What's that stand for? First outside, inside, last. So what is negative square root of 3 times 3? Negative 3 square roots of 3. Outside. So negative square root of 3 times negative square root of 3. That's just plus 3. The radicals are going to cancel. Now the inside, plus 9. And then last, 3 times negative square root of 3 minus 3 square root of 3. And that's all over. Okay. Now, I keep forgetting, for conjugates, do I need to multiply all 4 products? There you go. Does anybody want me to multiply all 4 to show you the inside-outsides will cancel? No? Okay. Well, let's see. What's 3 times 3? 9. Now, square root of 3 times negative square root of 3. Negative 3. Okay. So let's see. Let's combine my like terms. The 3 plus 9 will give me 12. There you go. Okay. Think of it like minus 3x minus 3x. That radical is just like a variable. Minus 6 square root of 3 all over 6. Now, can both of my numerators simplify with the denominator? Yes, so I would encourage you to break it apart. So 12 sixths minus 6 square root of 3 over 6. So what's 12 sixths? 2 minus square root of 3. There you go. Okay. I will say none of the other problems are as long as that. The tangents usually take a little longer because of the rationalizing. Okay. But you take it one step at a time, you're going to be just fine. Okay. So 2 minus the square root of 3. I'm going to come back over here. Okay, so right there, we've already got 2 problems done. Okay. And the only other problem that's going to be like it is number 5. The others should nowhere near take as much time as that one did. Okay. All right, how we doing? Questions? Okay. You guys did a great job. I'll tell you what, we will stop there.